Assalamu alaikum wa rahmatullah. Dear students, we have started an important unit from this Bilka part, that is surface chemistry. In that very unit we have delivered just 2 lectures on the surface chemistry. In those 2 lectures we have discussed some basics regarding the surface chemistry. Today we will discuss, in this very lecture number 3rd, we will discuss an important topic, that is the 3rd topic from the surface chemistry, that is factors affecting adsorption of gases on solids. Here you know, during the adsorption what happens, 2 things are being involved. One is adsorbate, the substance which gets adsorbed, that is adsorbate, and the surface on which adsorption takes place, on which accumulation takes place, that surface is known as adsorbent. It means that these are the 2 terms you have to mention. We have already mentioned. You have to remember here. One is adsorbate, the particles which gets accumulated, which gets concentrated on the surface, and the surface on which accumulation takes place, that surface is known as adsorbent. Here it is clear from the heading that you have gas. Adsorbate is gas, adsorbate particles, it is clear from this, it is gas, and adsorbent surface, that is solid. This is the topic. What are the various factors which affect the adsorption of gases, gas molecules on the solid surface? It means that adsorbent surface, here it is solid. But there are 5 factors you have to mention in this very topic. You have to mention 5 factors are there. The first factor will be adsorbent. ये adsorbent कैसा होना चाहिए, nature of adsorbent. The second, we have the gas, nature of adsorbate, you can call it nature of adsorbate. ये gas कैसा होना चाहिए. The third, temperature कैसा होना चाहिए. The fourth, that is pressure, and we have the activation of adsorbent surface. It means that while discussing this topic, you have to remember there are 5 factors. The first factor you have to mention, that is nature and surface area of adsorbent. Surface area of, this is the first factor you have to mention, nature and surface area of adsorbent. This is the first stop. This is the first factor. ये adsorbent कैसा होना चाहिए, whether the adsorption depends upon the nature of adsorbent or not. Remember this point. Let us take an activity. If you have the charcoal adsorbent, I have already mentioned it in the 2 lectures, examples of adsorbents. If you have the adsorbent, that is charcoal. If you have the silica gel, that is the adsorbent. You can take Al2O3, alumina जिसको हम कहते हैं, it is third adsorbent. Better if you take this an activity, simple activity to understand whether the adsorption depends upon the adsorbent or not. If you take 3 different adsorbents, and if you consider same gas, for example, you have the nitrogen gas, you have the nitrogen gas, you have the nitrogen gas. Better if adsorption does not depend upon the nature of adsorbent. If, let us this example, let us take the situation. If adsorption does not depend upon the nature of adsorbent, at that time what should happen? Adsorption rate will be same. जितना नाइट्रोजन यहाँ पे एब्जॉर्ब होगा, उतना यहाँ पे भी होना चाहिए, उतना यहाँ पे भी होना चाहिए. मगर क्या experimentally what has been observed that adsorption rates are different. Although the gas is same, although the gas is nitrogen is same, but adsorption rates are different. What it is clear from this activity that adsorption depends upon the nature of adsorbent. If you have different adsorbents, rates of adsorption will be different although you have the same gas. This is the first point you have to mention. Nature of adsorbent. Adsorption depends upon the nature of adsorbent. Remember this point, it depends upon the nature of adsorbent surface. And the second is surface area. Greater the surface area. If you have now charcoal, second activity, if you have charcoal this one, if you have charcoal this one, you have charcoal this one, greater the surface area. Among the three, there is greater surface area, this one. Here the adsorption rate will be high. You have to remember 2 points. The first point you have to remember that adsorption depends upon the nature of adsorbent. The second, greater the surface area of the adsorbent, greater will be the rate of adsorption. I will mention 2 points here. You have to mention, this is the first factor, the extent of adsorption. The extent of adsorption. Extent of adsorption. Adsorption कितनी हो जाएगी? Extent of adsorption depends upon nature of adsorbent. Depends upon the nature of adsorbent. The extent of adsorption depends upon the nature of adsorbent. Remember this point. If you take different adsorbents, the rates of adsorption will be different. Remember this point. Moreover, you have to mention, moreover, greater the surface area, greater the surface area, greater the surface area of adsorbent, greater the surface area of adsorbent, greater will be the adsorption rate. Greater will be the extent of adsorption, or you can say greater will be the adsorption rate, extent of adsorption. It is the first factor you have to mention, nature and surface area. Now you have to mention here in this very factor, you have to mention specific surface area. What is meant by specific surface area? ये जो specific surface area क्या होता है? You have to remember specific surface area. Specific surface area. You have to remember, sir, if you take 1 gram of adsorbent surface, 1 gram, specify the condition, 1 gram of adsorbent surface, अगर हम 1 ग्राम adsorbent surface लेंगे, 1 ग्राम adsorbent लेंगे, 1 ग्राम, इस 1 ग्राम adsorbent का surface area जो होगा उसी का नाम है specific surface area. वो अगर हम adsorbent 1 ग्राम लेंगे, उस 1 ग्राम adsorbent का जो surface area होता है उसी का नाम है specific surface area. It means, इसका माना क्या है? It means surface area of 1 gram adsorbent. 1 gram adsorbent. 1 ग्राम adsorbent का जो surface area होगा उसका नाम है specific surface area. इसका मतलब है, if you take 1 gram of charcoal, 1 gram of silica gel, 1 gram of aluminum at this point, at that time you can say you have chosen the specific surface area. This is the first factor you have to mention. The adsorption depends upon the nature of adsorbent and it depends upon the surface area of adsorbent. Now you have the second factor, nature of adsorbate. This is the second factor which affects the adsorption, that is nature of adsorbate. Nature of adsorbate. Here the adsorbate is gas. Here the nature adsorbate is gas. I will take the similar activity if you have the same, for example, you have the charcoal. If you have the charcoal, it means that here now I will take the same adsorbent surface. In the first activity we have taken the same adsorbent that is gas, मगर हम यहाँ पे adsorbent surface same रखेंगे. For example, यहाँ पे charcoal है. Now if you take the gas, different gas or different nitrogen gas, carbon dioxide gas, HCl gas. Let us assume that adsorbate एड्सॉर्प्शन डज नॉट डिपेंड, एड्सॉर्प्शन जो प्रोसेस है गैस पे डिपेंड नहीं करती है, नेचर ऑफ गैस पे डिपेंड नहीं करती है। देन व्हाट शुड हैपन, जब चारकोल यहाँ पे जो एड्सॉर्बेंट सरफेस इट इज सेम, अगर एड्सॉर्प्शन गैस पे मतलब डिपेंड नहीं करेगी एट दैट टाइम व्हाट शुड हैपन, जितनी एड्सॉर्प्शन यहाँ पे होगी उतनी यहाँ पे भी होगी, उतनी यहाँ पे भी होगी। बट इट हैज बीन फाउंड दैट इन दीज थ्री केसेस एड्सॉर्प्शंस आर डिफरेंट। Although the adsorbent surfaces are same, adsorption rates are different. What it is clear that adsorption depends upon the nature of the gas. Adsorption depends upon the nature of the gas. It means that if the gases are different, rates of adsorptions will be different. You have to mention. Then we discuss that what type of gas the gas should be. गैस का नेचर कैसा होना चाहिए, किस गैस में ज्यादा एब्सॉर्प्शन होगी, we will discuss this in this very factor. But first you have to mention here the extent of adsorption. The extent of adsorption depends upon nature of gas. नेचर ऑफ गैस, यहाँ पे जो गैस है इट इज एडसॉर्बेट, नेचर ऑफ गैस इट इज एडसॉर्बेट. रिमेंबर दिस पॉइंट. नाउ वी विल सी व्हिच गैस विल अंडरगो एडसॉर्प्शन टू अ ग्रेटर एक्सटेंट. किस गैस में एडसॉर्प्शन ज्यादा होगी, किस गैस में कम होगी, वी विल सी इट. We have an important topic we have discussed in the 11th class, that is critical temperature and liquefaction of the gas. You have to discuss, we will discuss this important point. अगर हमारे पास गैस है, for example नाइट्रोजन गैस, it is non-polar. Remember this point. If you have the HCl, it is polar. I will take these two examples. Now, if anybody asks you which gas among the two gases which will undergo adsorption to a greater extent, you have to see in which gas the gas molecules will approach to a greater extent. जिस गैस में मॉलिक्यूल जल्दी नजदीक आएंगे उसी गैस में एब्सॉर्प्शन ज्यादा होगी. यहाँ पे नॉन पोलर, यहाँ पे जल्द मतलब दे विल नॉट अप्रोच ईच अदर एट द फास्टर रेट, बट यहाँ पे पोलर नेचर प्लस माइनस यहाँ पे जल्दी होगा. इसका माना है ये जो HCl गैस है it is easily liquefiable gas. Easily liquefiable gas. Remember this point. Easily liquefiable gas. It is less easily liquefiable gas. It means that the gas should be easily liquefiable. It should, when the gas molecules approach each other, it undergo liquefaction. It will be converted into the liquid that is known as liquefaction. Remember this point. यहाँ पे liquefaction जल्दी नहीं होगी because the molecules are non-polar. They will not approach each other. Hence the liquefaction will be low. यहाँ पे liquefaction जल्दी होगी. You can say it is less easily liquefiable. वो ये जो गैस ये किस किस्म का होना चाहिए? It should be easily liquefiable gas. It should undergo liquefaction at a faster rate. Why it is easily liquefiable? You can mention it. Why it is easily liquefiable gas? Because of greater magnitude of intermolecular interaction. इसका माना है जिस गैस में magnitude of intermolecular interaction ज्यादा होंगे उसमें adsorption ज्यादा होगी. Because of magnitude of interaction, यहाँ पे interaction plus minus dipole interaction will be there. यहाँ पे interaction ज्यादा होगी, यहाँ पे इसलिए liquefaction ज्यादा होगी. उसका मान है यहाँ पे adsorption ज्यादा होगी. मगर यहाँ पे interaction कम होगी. जब interaction कम है, it means that gas molecules will not approach each other. यहाँ पे जल्दी नजदीक नहीं आएंगे. It means that they cannot be liquefied easily and hence they undergo adsorption to a smaller extent. It means that in nutshell you have to remember the gas it should be easily liquefiable. When the magnitude of interaction is high, it has greater liquefaction rate, it will have greater adsorption property, it will be adsorbed to a large extent. यहाँ पे magnitude of interaction, magnitude of intermolecular interaction, magnitude of intermolecular interactions are high. यहाँ पे interaction ज़्यादा है, मगर यहाँ पे interaction यहाँ पे कोई interaction नहीं है, प्लस माइनस नहीं है. लमिनर फोर्स विल बी देयर, यहाँ पे इंटरेक्शन कम है, लिक्विफेक्शन कम होगी, यहाँ पे एब्जॉर्प्शन कम होगी। हमने 11th क्लास में ये पढ़ा है जिस गैस में इंटरमॉलिक्यूलर इंटरेक्शन ज्यादा है उसमें एक टेम्परेचर होता है, उसका टेम्परेचर का नाम है क्रिटिकल टेम्परेचर। आपने ये पढ़ा होगा ग्रेटर द इंटरमॉलिक्यूलर इंटरेक्शन ग्रेटर विल बी द क्रिटिकल टेम्परेचर। वो टेम्परेचर होता है बिलो दैट, अबव दैट देयर विल बी नो लिक्विफेक्शन। लिक्विफेक्शन पढ़ने के लिए आपको क्रिटिकल टेम्परेचर, जहां पे आपने टीसी पढ़ा है, ये तो मस्ट है। जब ये टेम्परेचर, when this temperature is achieved, liquefaction will be there. अगर ये अचीव नहीं होगा, there will be no liquefaction। मगर ये जो क्रिटिकल टेम्परेचर है, it depends upon the intermolecular interaction। इसका माना है जब इंटरमॉलिक्यूलर इंटरेक्शन ज्यादा होंगे बिटवीन द गैस मॉलिक्यूल्स, क्रिटिकल टेम्परेचर हाई होगा। जब क्रिटिकल टेम्परेचर ज्यादा होगा उसका माना liquefaction will be greater। When the liquefaction rate is greater, it means that adsorption rate will be high. It means that there are 4 factors: intermolecular interaction, critical temperature, liquefaction, adsorption। intermolecular interaction ज्यादा होंगे, critical temperature ज्यादा होगा, they are directly proportional। when the critical temperature is high, liquefaction will be high। अगर यहाँ पे लेंगे, यहाँ पे absorption rate will be high। This is a very important point. You have to mention what sort of the gas should be. It should be easily liquefiable gas. It should have high magnitude of intermolecular interaction. It should have high critical temperature. The gas which has these properties, with these characteristic features, that gas will be absorbed to a greater extent. You have to mention this. What sort of the gas? The gas should be, it should be easily liquefiable gas. Remember this point. The gas in this factor, you have to mention this point. The gas should be easily liquefiable. This is a very important point. It should be easily liquefiable. It should be easily liquefiable. It's liquefiable means it should undergo liquefaction with ease at high rate. Remember this point. You can mention should be easily liquefiable. Remember this point. Now you can relate the adsorption. The extent of adsorption can be related. Extent of adsorption can be related. The adsorption, extent of adsorption can be related with magnitude of, this is the point you have to mention, magnitude of intermolecular interactions. Intermolecular interactions. That is, now you can relate, greater the magnitude of interaction, greater will be the critical temperature, greater will be the ease of liquefaction, and greater will be the extent of adsorption. That is, you can mention these 4. This is the relation you can mention. Greater the magnitude of interaction, greater the magnitude of interaction, greater will be TC. What is TC? Critical temperature. ये हमने 11th में पढ़ा है. Greater will be TC. Greater will be critical temperature. Greater will be critical temperature. Greater will be the rate of, greater will be the extent of adsorption. Greater will be the extent of adsorption. It means that in this case the rate of adsorption, extent of adsorption can be related with the liquefaction, it can be related with the critical temperature, the gas should be easily liquefiable. There are four factors: interaction greater, magnitude of interaction greater, critical temperature high, liquefaction rate high, and extent of adsorption will be high. This is the second factor. It means that adsorption depends upon the nature of gas. The gas should be easily liquefiable. This is the second factor you have to mention. The first is nature of adsorbent and surface area of adsorbent. The third is second is the nature of adsorbate, nature of gas. The gas should be easily liquefiable. The third factor, that is temperature. That is temperature. That is temperature. जब हम टाइप्स ऑफ एड्सॉर्प्शंस पढ़ेंगे इन द नेक्स्ट लेक्चर, फिजिकल एड्सॉर्प्शन एंड केमिकल एड्सॉर्प्शन, जब हम फिजिकल एड्सॉर्प्शन की बात करते हैं, व्हेन वी टॉक अबाउट द फिजिकल एड्सॉर्प्शन, जब हम टाइप्स पढ़ेंगे वहां पर आपको अच्छे से समझ आएगा. यहाँ पे भी इंशाल्लाह यू विल गेट दिस पॉइंट, फिजिकल एड्सॉर्प्शन. Physical adsorption में actually there are no strong bonds, there are weak van der Waals forces, no chemical bonds are being formed, no covalent bond is there, no ionic bond is there. Physical. जब chemical adsorption कहेंगे वहाँ पे chemical bond is being formed. ये जो physical adsorption है, for example, dust particles get absorbed on the board. There is no chemical bond formation. Weak van der Waals forces are being formed between the dust particle and the board. It is physical. Remember this point, when there is no chemical bonds between the gas and the solid, it is physical adsorption. Remember this point. And if you apply the force, what will happen? Gas will come out, the dust particles will come out. It means that ये जो physical adsorption है, it is reversible in nature. जब हम physical adsorption अलग से पढ़ेंगे, वहाँ पे आपको समझ आएगा जो physical adsorption है, it is reversible in nature. You can remove the dust particles from the board just by rubbing. Remember this point. What happens? You have to remember ये जो physical adsorption है, it involves an equilibrium process. It involves a true equilibrium. You have to remember physical adsorption involves a true equilibrium. Involves a true equilibrium. True equilibrium. Involves a true equilibrium. Yeah, it involves a reversible. It is reversible in nature. You can remember this. True equilibrium means it is reversible in nature. How you can represent it? If you have the gas, it is adsorbate. You have the solid. Let us say it is the dust particle. It is the board. Gas and solid. This is it is reversible. There are two opposite processes. One is gas molecules, they approach and get condensed. That's condensation. This is condensation, जिसको हम कहते हैं adsorption. Remember this, when the gas molecules come and stick on the surface, it is condensation. And when they leave the surface, they will go apart. When they move apart, that is evaporation. It means that ये जो adsorption है, physical adsorption की हम बात करते हैं, it is reversible in nature. It involves a true equilibrium process. From this point, the first process, condensation, when the gas molecules come and concentrate on the surface, this is condensation. And evaporation, they go apart from each other, that is evaporation. इसका हम दूसरा नाम आपको याद रखना है, that is adsorption. Condensation is actually adsorption. And evaporation, it is desorption. जब गैस मॉलिक्यूल सरफेस से बाहर जाएंगे, it is desorption, and you get gas adsorbed on solid. Gas adsorbed on solid. When this process condensation takes place, what happens? Some amount of heat energy is being released. Plus heat लिखेंगे. This is the way. It means that the forward process, condensation process, adsorption process is exothermic in nature. While the backward, definitely in the equilibrium, we have discussed if the forward is exothermic, backward will be endothermic. Remember this point, it is clear that the forward process, the adsorption or condensation, it is exothermic in nature. Energy is released. You have to first remember this equilibrium. It in the adsorption involves, it is reversible in nature. it involves equilibrium process. The two processes are condensation, that is adsorption, and the second evaporation, or you can say desorption. The second point you have to mention, the condensation, adsorption process is exothermic in nature. Definitely the backward process, evaporation and desorption, it will be endothermic in nature. Then you can apply the Le Chatelier's principle. L principle जिसको हम कहते हैं Le Chatelier's principle. Le Chatelier's principle के हिसाब से if you जो forward है, it is exothermic in nature. Energy comes out during the adsorption. But ये जो backward है, यहाँ पे हमको energy देनी पड़ेगी. It means that absorption, it is exothermic in nature. ये जो adsorption है, it is exothermic, and desorption, it is endothermic. Endothermic. Remember this point. It is exo, energy is released in the form of heat, and this one is endo. Now, if you increase the temperature, we have to discuss the effect of temperature. If you increase the temperature, it means that we are supplying energy. Why do we need to supply energy? Either in adsorption or desorption. In desorption, we need energy because it is endothermic in nature. If the temperature is high, जब temperature increase करेंगे, it means that we are favoring the backward setup. Because we are supplying energy, we are favoring the evaporation, we are favoring the desorption because it is endothermic in nature. It means that in physical adsorption, high temperature favors endothermic, it favors desorption. And low temperature, if you decrease temperature कम करेंगे, we are not supplying energy, it means that low temperature will favor adsorption and high temperature will favor desorption. आपको यहाँ पे याद रखना, we can explain it on the basis of L principle. I will explain it again. Since the adsorption, condensation, forward is exothermic, energy gets released. We don't require any energy. But the backward, it is endothermic, we have to supply energy. Now, if the temperature is high, we are supplying energy. What it means? We are favoring the desorption, we are favoring the evaporation. It means that high temperature will favor desorption, low temperature will favor adsorption process. Remember this point. You can mention these points. The forward process. You can mention the forward process. The forward process is exo. The forward process. ये forward process, whether it is adsorption or desorption, it is adsorption. Forward process is exothermic in nature. Exothermic in nature. A forward process, adsorption is exothermic in nature. Hence, on the basis of Le Chatelier's principle, on the basis of Le Chatelier's principle, Le Chatelier's principle, Le Chatelier's principle, we can say high temperature will favor, you have to underline this point, this is the important point, high temperature will favor backward process, backward process क्या है? Desorption, while low temperature will favor forward process, and what is forward process? That is adsorption. It means that you have to mention this important point. This is the point you have to mention. Low temperature will favor physical adsorption. Around this point. It means that low temperature will favor adsorption, high temperature will favor desorption. You have to mention it. Now we have the term here, heat of adsorption. Heat of adsorption. ये जब हमने वो पहले लेक्चर में दूसरे लेक्चर में पढ़ा था वो थर्मोडायनेमिक क्राइटेरिया ऑफ एड्सॉर्प्शन, डेल्टा एच को क्या होता है, एंट्रोपी को क्या, तो वहां पे हमने हीट ऑफ एड्सॉर्प्शन पढ़ा है. व्हाट इज हीट ऑफ एड्सॉर्प्शन? द अमाउंट ऑफ हीट रिलीज्ड. ये हमने वहां पे पढ़ा है. द अमाउंट ऑफ हीट, amount of energy, it comes out in the form of heat. The amount of energy released when one mole of adsorbate, when one mole of gas gets adsorbed. The amount of energy released when one mole, जब एक मोल गैस एब्जॉर्ब होगा कितनी एनर्जी रिलीज होती है, उसी को हम कहते हैं is known as heat of adsorption. Amount of energy released when one mole of the gas gets adsorbed, it is known as heat of adsorption. The first factor we have discussed nature of adsorbent, surface area of adsorbent. The second factor we have discussed that is nature of adsorbate, and the third factor we have discussed that is effect of temperature. Temperature, whether temperature should be low for physical adsorption or high, it should be low because low temperature favors forward process. The fourth is pressure. If you have gas molecules, we want their adsorption. What the pressure should be? Pressure should be high. In general, greater the pressure, greater will be the adsorption. Because when we apply the pressure, gas molecules approach each other and they will undergo adsorption. You have to mention in general, greater the magnitude of pressure, greater the magnitude of pressure, greater will be the extent of adsorption. It means that you can remember an important point. What are the temperature and pressure should be for physical adsorption? Low temperature and high pressure favors physical adsorption. You can mention this important point here. You can mention it. Low temperature, low T and high P. High P favors, you have to mention it. Low T and high pressure favors physical adsorption. When the interaction between the adsorbate and adsorbent is weak, that is physical, we have to discuss the types of adsorptions, but you have to remember this important point. Low temperature and high pressure favors physical adsorption. Now we have the last factor, that is activation of adsorbent surface. Activation, the fifth factor is activation of adsorbent surface. What the activation means? You can mention here, activation means to increase the adsorbing power. Activation हम किसको कहते हैं? When you increase the adsorbing power of the adsorbent surface, we can say we have activated it for adsorption. We have activated the adsorbent surface for adsorption. Activation means to increase the adsorbing power of adsorbent surface. It means activation. What the activation means? To increase the adsorbing power of adsorbent surface. It can be achieved. It can be achieved by the first point. You have to mention how we can increase the adsorbent surface. If you have, for example, adsorbent surface, gas has been already absorbed it. Now we want to increase its absorbing power. We want to, there should be more adsorption. How we can increase its absorbing power? How we can make the adsorbent surface to undergo adsorption more? We will remove the already absorbed gas. ये जो already layer है, we will remove it. When you remove it, what will happen? There will be more and more adsorption. When you remove the already absorbed gas, by this we can increase the absorbing power of the adsorbent surface. The first point is by removing the gas, already adsorbed. When you remove the gas already adsorbed, by that what will happen? Now the adsorbent surface will be available for adsorption. There will be more adsorption. The second point, we can do it. Second point, you can mention A, you can mention B, by making the adsorbent surface rough. Rough, because it has been found that when the surface is rough, there will be greater magnitude of interaction, there will be greater magnitude of van der Waals interaction. By making the adsorbent surface rough, either by mechanical rubbing, we will rub it to make it rough, or by any chemical methods. When the surface is rough, there will be greater degree of adsorption on the adsorbent surface. The third point, we can increase the surface area by subdividing. The third point is by subdividing the adsorbent. What is meant by subdividing the adsorbent? By subdividing the adsorbent, when you divide the adsorbent, this is the compact form of adsorbent, this is the solid form of adsorbent. If you divide it into the small pieces, by what happens? By dividing it into the small pieces, surface area increases. When the surface area increases, this is the compact form, this is the porous form, powdered form. Remember this point. It means that by subdividing the adsorbent, what happens? Surface area increases. When the surface area increases, the rate of adsorption will also increase. Hence, we generally prefer the adsorbent in the porous form. We generally prefer the adsorbent in the powdered form, because in the powdered form there is greater surface area. By subdividing the adsorbent, by this the surface area increases. When the surface area increases, the rate of adsorption will be high. These are the 5 factors which affects the rate of adsorption. Remember this point, adsorption of gases on the solids. Remember this point. Now we will discuss an important topic. I will list the important topic, types of adsorption. We will discuss the fourth topic, types of adsorption. This is the question which comes in the exam. On this point, this is a very important topic, types of adsorption. On the basis of interaction between the adsorbate and adsorbent. Let us say this is adsorbate, this is adsorbent. What sort of interaction lies between these two? Whether the interaction is weak van der Waals type, or the interaction is strong chemical bond, covalent bond, ionic bond. We have two types of adsorptions. The first, when the interaction is weak, that is physical adsorption, and when the interaction is strong, that type is known as chemical adsorption. You can mention on the basis of interaction, nature of interaction between the adsorbate and adsorbent. We have two types of adsorptions. You can mention it on the basis of magnitude of interaction. On the basis of magnitude of magnitude of interaction between adsorbate and adsorbent. We have two types of adsorptions. We have two types of adsorptions. The first, I will first list the names. The first is physical adsorption. Or you can call it physisorption. Or you can say van der Waals adsorption. It is clear from this name that the interaction between the adsorbate and adsorbent, it will be weak of the type and Waals, hence van der Waals adsorption. The second, we have chemical adsorption. This is the important question which comes in the exam. Chemical adsorption or chemisorption. Or it is also known as Langmuir adsorption. Or it is also known as, because it involves the formation of real chemical bonds, and you know for every reaction we need some energy. आपने chemical kinetics में सुना होगा activation energy इसको हम कहते हैं, so that the bonds will be formed. Hence it involves chemical bonds, hence we have to increase temperature, hence we have to supply energy, hence it is known as activation, activated adsorption. It means that on the basis of interaction between the adsorbate and adsorbents, we have two types of adsorption. This is a very important question. The physical adsorption, also known as physisorption or van der Waals adsorption, and the third, we have chemical adsorption, or we have the Langmuir adsorption. In the next lecture, inshallah, we discuss this very important topic, that is physical adsorption and chemical adsorption. Till then, fi amanillah.